So we have Eric with his second presentation of the day. What can only be done with IPv6? And I'll leave the stage to Eric.
Okay, good afternoon. And basically in this short section, I would love to see you what can be done with IPv6 and cannot be done with IPv4. Because we talk about IPv6 for the numbers of addresses, but actually it goes beyond. So if you look about it, what are the main differences between IPv4 and IPv6? First is the extension headers that can sit between the IP header and the TCP or UDP or CTP header, as you know. Of course, we have way more addresses in IPv6. So what can we do with all those addresses? Not only fight and win the battle against CGN, but we can do more. And as well, another minor difference, but important, is that on IPv6 you can have multiple addresses per single interface. And moreover, nowadays all the computers has got multiple interfaces, right? Bluetooth, Ethernet, wide. Okay, so let's say what we can do with extension headers. And for instance, one thing that we can do, and the IETF is standardizing right now, is basically what we call segment routing. Segment routing is using the routing header. And within the routing header, you can get multiple types of it. We know that type 0 is pretty bad because it's plain source routing, which is insecure. But 2 is about a mobile IPv6, and so on. So with using segment routing currently defined in the IETF, we can use each segment in the routing header. There are multiple segments, right? First hop, second hop, and so on. It's called segment into the RFC 8200, the new IPv6. We can do basically network programming. I just wonder, do you see my slides? Okay, fair enough. So with this, we can make NFV, so network function virtualization, way easier because we can basically say, go to this function, this function, and this function, and this function. So easy. And we can even do something like a very advanced load balancing at layer 3. So we can move load balancing from layer 8 for some function to layer 3. If you want to know more, this is segmentrouting.net. We can also leverage this segment routing header to do what we call in situ OAM, operation, administration, and management, meaning that each and every packet in band, that's very important, will mark, and every router on the path will mark, I send this packet at that point of time. So it allows basically for measuring the latency in all the links and each and between and every network function. But we can as well ensure that all the network virtualized function has been enforced. So we can be sure, for instance, that it has gone through a firewall or to an antivirus or whatever. Again, there is an IETF we can group there. There is a link. So it was for the headers. But we have as well way more addresses in IPv6, right? So way more. And one example, and we start to see it in the data center. If you're using containers, and I guess most of the people here are more from the networking side of the industry, containers are basically a very ultralight virtual machine. So if your host, having all those containers, is an IPv4 host, and you are starting microservices, one per container, let's say with a single very simple function, you share this IPv4 address. So meaning that each and every container whose lifetime is maybe 1 second, 2 seconds, or maybe 1 year, will have to use the same IP address, IPv4 address, but the different port. So meaning that you need to be flexibility there and basically do some ugly nut on the host for doing v4. While in v6, and especially if you do a /64 per host, and that's bringing as well some more security for other reason. Now with a /64 per host, you can give a /128, so a full IPv6 address, including all the UDP and TCP ports. So now for the container itself, it runs natively. It doesn't really see it has been NATed or whatever, making things way, way, way simpler. And in a /64, you have many, many, many of them. So an address will never be reused in your lifetime, even if you have many VMs and many containers. We can do even more. I don't know how much you know about video distribution, but if you look at YouTube, the Netflix of the world, basically each and every movie is cut in very small chunks of 2-3 seconds each that allows you basically to move directly at any point into the movie. And the movie itself is encoded in different resolution. We call it profile, basically whether it's a small definition, high definition, on a small phone. So assume you have a 128 bits of an address, and you get 64 bits on the left-hand side, which is your prefix. You have now 64 bits as your interface identifier per RFC. But those 64 bits, you can use it like this. Don't look at too many of the details in this graph. But basically what you can do, you can use, for instance, the middle 26 bits to define more than 70 million of movies. And you use 4 bits on the right, you can define 16 profile. It basically defines you whether it's a small device or large device and something like that. And you can use 16 bits at the end just to see it's sequence number 1, 2, or something like that. I will go in a bit more details later, but again, an URL, if you want to try it, you obviously need IPv6 to go and see all the goodies that are there. So typically, if you use a CDN, a content distribution network, for instance, with Apache Traffic Control, which is open source, you need to go first when you ask for an URL like example.com to get a movie. You go first by using a DNS request to the nearest content router. So already the DNS server needs to know which is the nearest DNS server close to me. Then the content router will do redirection, either based on HTTP or DNS, to the nearest cache from the user, which is alive. No need to want somebody refer a subscribers of yours to that cache. And then you get the hierarchy of cache level 1 and 2. It's working, don't take me wrong, many people are using it, but if you use IPv6 to identify any of those small chunks, and if we use anycast routing, so that each and every edge cache is basically injecting into the routing protocol the same anycast address, you will always go to the closest routing-wise cache, and if one cache is going down, basically what you got doesn't inject the route anymore, and you get a fast failover to the nearest cache, which is alive. Also, as we put content and we put basically semantics into the V6 addresses, if we're using NetFlow IPfix, you can go and make some very nice and interesting statistics. Again, no more details there, but we can use addresses, way more addresses to do many things. Another point that is unique with IPv6 is that we can have multiple IPv6 addresses per interface. Why is it important? Because now we can get an application on the left-hand side, and you can get a router giving out access, in this case, two very basic services. For instance, one which is a VPN back to the corporate, we can check email, or what you call a local breakout to go to the internet in direct without going there. But you can imagine as well a walled garden for video distribution or whatever. As we can have multiple V6 addresses per host, now the host on the left-hand side could have two addresses, one in each prefix, one prefix being used for the VPN and one prefix going for the local breakout to the internet. And it's up to the application now to select the right source address, and it will be routed correctly by the network infrastructure. Now, how can the host discover basically which prefix needs to be used for which kind of application? This is where, and Jen and Kova talk briefly about it, that is a draft IETF document that we define with Apple and as well as with Google about PVD, provisioning domain. It's basically, let's say it's route advertisement, we advertise all the capabilities of this source address, whether it's a walled garden, which is a captive portal, whether it's for doing VPN or whatever, together combined with a right routing. So basically, what I want to say is that we can do way more in IPv6 that we can do in IPv4. To summarize, extension headers can prevent the ossification of the IP stack, because that's how we can add new feature without adding a new version in IPv6 or whatever. And by the way, if there are any service provider in this call, please do not block extension headers. I mean, some people are blocking them. You may want to do it at the perimeter of an enterprise, but not at all into the internet. We've seen as well that many addresses allow for microservice addressing, whether the microservice is a containers running into a machine in your cloud or in your data center, as well as delivering content like a chunk of a video, for instance. And by using multiple IPv6 addresses per interface, what you can do is simply allow the application, if it receives the information through PVDs, right, the protocol we are defining, then it can select the right source address, and it will get a different routing, quality of experience, quality of service, security based on this choice. So yes, we can do way more in IPv6 than we have been able to do in IPv4. And honestly, we start doing this kind of research only for 2-3 years, so we've only scratched the surface of what we can do in IPv6 that we cannot do in IPv4. And there's the last slide. And as far as I know, Max, we will get some kind of discussion after, right, for the question.
So far, I haven't seen any questions for Eric, but since we're going to have a panel, a little bit of a panel later on, I'll just leave them. I'll just leave them for later. So now let's try again with Fred Baker. Are you still with us, Fred?
Well, one hopes.
Let's see if we can get you to present. Perfect. That looks good.
Okay, cool.
Okay.
Okay, so you asked me to talk about kind of what's going on, what do I see going forward? And I thought I'd talk a little bit about what we're seeing in V6 Ops and in other places. I'm going to use a couple of slides that come from other presentations. I would imagine that Eric showed something like this earlier today. This is looking at the TLDs that are that Google claims are giving it 5% IPv6 or more. And of course, Belgium is right up there at the top. Belgium's doing very well. We've been looking at the statistics from Google and from RIPE, or Google and Akamai and APNIC quite a bit over the last few years, and they've been very interesting to see. At the last IETF meeting, George Michelson from APNIC went through a study of which economies are actually generating the most traffic. And he did this with the ISOC policy people, and he showed this slide, which, by the way, at the IETF meeting in Montreal in a few weeks, I'm sure we'll see this slide. We're going to have him present in V6 Ops. But you notice that the countries that showed up very high on this, including Belgium, actually have very low traffic as measured by the ISPs. Belgium, he says, is in the neighborhood of 1% of its traffic. And so I found myself thinking and wondering, okay, so what's the difference and why? Well, India is as high as it is basically because Reliance JIO has almost no IPv4 capability and is carrying IPv6 entirely internally, and almost single-handedly is making traffic into and out of India be 20% IPv6. There's really quite a bit of traffic within that network that's using the capability. The USA is behind them, and I find this interesting because I've been all over the world and had people tell me, well, I'll think about deploying IPv6 when the United States starts deploying IPv6. Well, guys, the United States is deploying it. We're seeing some traffic. But the countries that we've been pointing to and saying, this one seems to see an awful lot of traffic, aren't necessarily up there, at least according to his measurements. And so I find myself thinking, why? Well, so who are the networks that are doing a lot of this? Well, mobile, for one. If you've been watching the statistics, Taiwan over the last 6 months has gone from almost no IPv6 traffic to right now it's on the order of 10 or 12%, and there's a particular network that's in the neighborhood of 25 or 30%. What's happening? Well, the mobile networks are running a lot of IPv6, and they're running 464XLAT or something like it at the edge in order to connect to the IPv4 network when they need to. A big part of the IPv6 story right now is with mobile. Residential broadband, of course, is a big part of it. Each of the major ISPs in the United States is now IPv6 capable. My kids have teased me about IPv6 for years. And the funny thing is that they all have it in their homes. None of them realize it, and they all use it. And of course, we're seeing a lot with data centers and content. You heard earlier from Mythic Beasts, and I imagine other people during the day. The question is the difference between the statistics that we see. When I have an end-to-end path that uses IPv6, I have a very good probability that I'm actually going to use it. And we see that with the Google and the APNIC and the Akamai statistics. If I've got an end-to-end path that is IPv6 capable, lo and behold, I see IPv6 traffic. But when one link in that chain is not IPv6 capable, somebody turns it off or fails to turn it on, then we don't see that. What we see is IPv4. And I have to interpret the statistics that I'm seeing in various European countries as, well, Google and APNIC and Akamai are IPv6 capable. The networks are all IPv6 capable. The residential domains are IPv6 capable. But the website that they're going to, some enterprise website, is only IPv4. And so for a lot of the traffic, lo and behold, it's still IPv4. It's still legacy traffic. So a while back, IPv6 operations, V6 Ops, started looking at this. We added this as a point to the charter and started pretty seriously trying to ask, what do we need to do to move into enterprise, to move into the part of the network that is still not turning on IPv6. Microsoft spoke to us about their internal activities going on. They're actually in the process of turning off IPv4 within the company. They haven't gotten there yet, but they're moving in that direction. Facebook, of course, has been pretty public about moving in that direction for a number of years. And there are other companies that are going that way too. And the reason that they give for wanting to do that is basically to simplify their networks. Eric spoke a few minutes ago about a /64 to a host and how it simplifies the applications and the things happening on the host. And it does. And companies are moving in that direction for that reason. So my question, and this would be an open question that we can perhaps discuss in the panel discussion, and I guess Jen talked about it earlier today as well. How do we encourage enterprise deployment? How do we raise this on their radar, not as a, gee, I want you to do this, but as a solution to a problem that they have, a problem of complexity, a problem of cost, a problem of managing the application. I do like Mythic Beast's approach. You know, if we're selling addresses or leasing addresses to somebody, let's charge them for the addresses. And you know, maybe we can move in the direction of them choosing the cheaper addresses. If we can move things in the enterprise domain, then we should be seeing a lot more IPv6 traffic, and we should see a switchover over time. Now, Eric opened a thread on Facebook a couple of days ago, and he asked, or you know, he pointed out in this session and said, guys, you know, let's talk about it. And somebody made a comment in that thread and suggested a final slide for my talk. So here it is. Yes, it's time to turn IPv4 off. We don't need it anymore. Let's simplify our networks. Let's reduce our costs. Let's move in the direction of V6 only. So, okay, Max, back to you.
Thank you very much, Fred. So this was an interesting, very interesting presentation. Thanks. So now to look at a slightly different perspective, we'll have Silvia Hagen. So we will request control from you, Fred, to be able to share the screen from Silvia. Yes, there we go. And so Silvia is going to give us a slightly different perspective. Yes, up to you, Silvia.
So yes, as you heard, a different perspective. I was thinking that I don't want to talk just about the future of IPv6, but about the future of the internet, which will just require IPv6. It's not going to happen without IPv6. So I'm sort of like taking a bit bigger picture and not just nailing it down to technical features, because Eric has beautifully covered that. So I was thinking about where's the internet going? And I'm just going to make this pretty short, so we may have some time for discussion. If you want to read the full story, I wrote a blog on it, and you can see the link on the slide, which you can download. And the buzzword is decentralized web. So everything is going to go decentralized. It's just going to be a new option. It has already started. Many people are using blockchain as one of these technologies. And I'm sure there will be many more of this type of technologies, which are decentralized. So if you want to dive into this topic, there is a link to the Decentralized Web Summit with many talks of interesting people, including Vyncke and Tim Berners-Lee. And if we look at services that are already showing up, so you have the last bullet, which is the IPv6.io. It's a decentralized web service which replaces HTTP with a peer-to-peer hypermedia protocol. Blockchain can be used, so cloud can go blockchain. Like the first bullet includes a link where you can go and look at this company that offers cloud services based on blockchain. Then we have the interplanetary file system, which you can use today. You can just download some apps and scripts to use it right away. And this was, for instance, used, maybe you have heard about the Catalan independence referendum last fall. And the government tried to sort of close Wikipedia. And so the ISPF, the Internet File System people, they created a Wikipedia mirror based on blockchain. So it wasn't possible anymore to sort of use centralized censorship. And then microservices are coming up, OpenShift, containers, like Eric also explained how IPv6 is going to help with this. And there is a link to an article which discusses how many industries will be disrupted by blockchain type technologies. And I'm saying this all because these are all end-to-end technologies, and they're only going to happen with IPv6. And security and data protection, we have GDPR coming up, and the address space of IPv6 allows to be more specific with like certain regulations. For instance, if you want to limit access to certain countries, it's easier to do that with IPv6. It's almost impossible to do that with IPv4. And here I like to state one example of how IoT can be a business driver, which will finally help IPv6 to sort of jump. It's the Swiss train company, SBB, and they have done their whole planning like back in 2014. They made an address plan, they made a roadmap, and then they said, okay, now we're sort of ready and we're just going to wait. Well, they waited until last summer when business came to the network group and said, listen, we're going to launch our first IoT app for train passengers. The launch date is Q1 2019, and we have 1,200 trains, and we need 1,000 IP addresses for each train. So the network group says, forget it, we don't have so many IPv4 addresses. So guess what? The app will have to be IPv6 only because they don't have any IPv4 addresses left. And so now we can see this will only work with translation. But had they continued deploying IPv6 internally, they might have had a chance to have their backend and their backbone already upgraded to IPv6, and then they wouldn't need translation. So this is a good example for enterprises why they should move ahead also in the internal network. So my perspective is the future of the internet can only be guessed. We live in a highly transitional time, both with regard to technologies and social impacts and developments. nobody can really say what the internet is going to look like in 5 years. And there is also a new generation at the horizon. My daughter is 30 years old, and these people, they are totally different, and they are entering now the business world and the political world, and they will make different choices about how they want to use the internet. And we know that new technologies can emerge overnight, just like blockchain sort of emerged overnight, and tomorrow it can be something else. So the challenge is, how do we use technology in the future? We have all those cybercrime topics like coming up, because it's one thing if my website is attacked, but if somebody reroutes my car while I'm on the highway, or manipulates my heart rate controller, or maybe my, I don't know, water dam, then I have a real issue. So cybercrime becomes much more dangerous. And then we have this whole trust and freedom versus fear and control thing going on. It's like the internet, and I mean, Facebook has been in the news. They all collect data. Sorry, that should be through data collection. There's a typo. And the question is, what do we do with it? And it can be used in a positive way, or it can be used in a negative way. So somehow I believe that the internet is like a mirror of human collective consciousness and society. And even Vyncke mentioned this in an interview with a Swiss magazine. They asked him if V6 would solve the issues, the security issues that we have in the internet. And Vyncke answered and said, you cannot solve these issues on a protocol level, because the internet is a mirror of society. So we have to solve these issues on the other level. So I want to thank RIPE for offering the opportunity to celebrate World Launch Day, and let's all together create a healthy future internet. And we can do that by making daily decisions and take actions that are based on trust and not on fear.
Well, that's thank you very much for the presentation, Silvia. So now I would ask both Fred and Eric to also open their microphones if they can. And yeah, because I collected a few questions, and now it's time to see if we can have a short discussion about these three presentations, about the views we have. I was discussing a bit before we started this session with Silvia and Eric, and we were thinking, like, looking at the material we have, looking at the slides, we have three different points of view. One is the technical point of view that was shown by Eric. Then we have the statistics by Fred, and then Silvia was giving us a broader view, like what do you think might happen here. But my question is, we have looked at the slides, asking for what could be the encouragement, like can we encourage enterprise deployment for IPv6? But at the same time, we were asking ourselves, is the IoT the real driver for IPv6? And the two things can be probably put together, but at the same time, an enterprise looks less at IoT than an end user. Probably the end user is probably one of the real drivers of implementing the IoT. So what do you think about this?
Well, I think that the SBB, the train company example, is really actually showing, I mean, it's the company that decided that they want to launch this IoT app for passengers. And I think this is going to be happening more and more. That's why I like this example so much. And this is like the first step. They're going to like make this bigger. So I can, from the train, use the app to rent a bike or a car when I arrive at the next station. And I see all these services expanding. And that's now just the train company business. But I see like the energy sector, the healthcare sector, they all have similar new technologies emerging, which are somehow, well, maybe we shouldn't call it IoT based, but just requiring a lot more apps and connections, which are hopefully going to be end to end.
Okay. Eric?
And if I may want to add a few words, as we all know, there are different kind of IoT networks. They are the one where You can go via the cloud to look about the TV camera surveilling your door at your home. Or there is the real IoT, I mean, the real industrial IoT, like smart grid. And for instance, I am aware of a big deployment of multiple millions of smart meters in Canada by BC Hydro. All of those smart meters and the solar, everything is linked over a radio to the next one. So they're making a mesh of those things. Everyone is having a unique IPv6 address with IPsec tunnels and everything. Pretty cool. It works. Very large, mostly the largest internal only IPv6 network worldwide, but it doesn't go to the internet. It stays closed. So there are multiple IoT network. This one is IPv6 only because they have no choice. There is no IPv4 addresses anyway for this size of deployment if they want to do it well. Excuse me. So I'm not that sure that IoT will help a lot moving towards IPv6, and it's even a road blocker in some place. For instance, if you think about IoT like putting an address into the lighting system, into the warming system, into all the building intelligence, or the card reader in front of the door. For instance, again, sorry to explain from my own company, but and Fred will remember, we have a building in San Jose, which is as much as we can IPv6 only, but for all the card readers or for all the building information, automation, we still need to get a specific VLAN doing IPv4. And talking with basically Veronica from Microsoft and others, they are facing the same issue. It's easy for computers, it's easy for data center. IoT, I don't see it really as leading forward, specifically when those devices are there for 30 years.
Fred, would you like?
Oh, yeah, and there's kind of IoT and IoT and IoT. As you mentioned, there's a lot of walled gardens in IoT, and you can have very large deployments that really can only talk to themselves, and that by design for security reasons. I think mobile is going to remain important, and of course we're seeing a lot of V6 activity in mobile. But mobile is going to remain important simply because a lot of people carry them. And Silvia, when you talked about the apps that people run, well, those apps are primarily running on their phones. So, you know, I think mobile is going to be important there. Blockchain, I've got a guy at Tsinghua University that is starting a company based on IoT and blockchain, and basically trying to turn his PhD into a revenue stream. He and I have been talking about that. I think blockchain is going to be pretty important as an identity device and as an information sharing system.
But back to your questions, Max, I'm not sure what we can do as an incentive to increase the deployment of IPv6. Inside enterprise. There are some enterprises that are facing not enough IPv4 addresses, but besides it, except if we go to something like I mentioned, if you want to get a massive containers deployment and with a nice orchestration, then a /64 per host helps, but you cannot get a /64 out of a /32 IPv4 address, right? So maybe this kind of stuff one by one will help. But
it is also true that the last time I checked, many of the tools you use to manage containers and the orchestration also didn't support IPv6. So we also have to look into that.
Yeah, Kubernetes now support IPv6.
Okay.
So it's recent, right? A few months. So.
Okay. So that's news for me, and that's probably news for a lot of people here listening to us. So that was also another point in my notes here. Yes. So then let me move on to, I have another question. So we're talking about taking day-to-day decisions, and this is true for everyone. What we do every single day influences in the long run how IPv6 will be doing later on. But looking at what we're doing now, there is, I don't know if you've seen that, but there is a working group at the ITF called the Sunset 4, and people have started suggesting to close that working group because work has been done. Work is done. We should put it behind our backs and just look at IPv6. What do you guys think about it? Well, I know it can be a tricky question, but
Oh, you mean closing the sunset group?
yes, there was a proposal. there was a proposal to close it. Although there are still some proposals open in the group, but yeah, Sunset 4 is closed at the moment. See Jordi commenting it.
Yeah, but Sunset 4 was mainly for planning it, because at some point of time we didn't get the right protocol to signal, for instance, to the protocol stack that there is no more IPv4, so there is no need to fall back to the 169.254, which is the link local address for IPv4. So a few things like this. So I think the work group is complete now. But if the question that you have in mind, Max, was when shall the last IPv4 address die because the computer has fallen in dust or is being disconnected? I'm pretty sure we have in some place still some network in very old plan running DECnet or running AppleTalk or even Token Ring somewhere.
Yes.
So I see at least IPv4 living in some place at least for 20 years.
Okay.
But majority being IPv6, right? Don't take me wrong.
Yes. Any other thoughts on this? Maybe Fred or Silvia? No.
Oh yeah, I would agree. I would agree that IPv4 is going to be with us for a while, basically because somebody, their cold dead fingers aren't letting go. But the question is really the most important utility and the value. I think as long as we have enterprise saying, well, I'm going to hide behind my IPv4 and NAT, then they're not going to let go, and it's going to be important at least within those domains. At some point, though, I expect them to decide that it would be simpler to run the same protocol end-to-end, and they would spend less money debugging problems, this, that, and the other. For enterprise, I would expect that the economic advantages and the security advantages would be the things that'll be their drivers.
Okay. Well, thank you. Do we have any other questions or any other topics that we would like to? Because we've run into the next session for 10 minutes. Well, the next session we run into the we're running 10 minutes late. But yeah. Anything? Because I see someone typing. There is Kurt Kaiser saying, well, I believe since the internet has very quickly enabled people to act together in a more organized way, many have shifted now their focus on how to gain control over the net politically, technically, financially, or simply with suppression. It is very much less of a question of a technical, question between IPv4 versus IPv6, rather on access, ubiquitous, and uncensored content in order to get free speech a good chance. The more we help to deploy a neutral network for all kinds of uses, ultimately this will bring most value for everyone. And that's true. And then I think this can also, well, independently of the protocol, if it's IPv4 or IPv6, that represents an important step for the internet, an important part. And that's one of the goals of the RIPE NCC, is also to provide to everybody making the internet a better place. So that's also part of what we think here. Yes. Yes, I see people typing, so probably we have some more points of view or questions or anything. Let's wait for Jordi to type in. Because in the meantime, I can't think of any more questions. Is there anything else you would like to discuss?
Well, Switzerland is voting this coming weekend, and you should all watch it because it's about net neutrality, and the government wants to impose so that they can force ISPs to filter, and we'll just see what people decide on Sunday.
But you have already voted. You have already sent your vote, right? Or
I have.
Yeah, there you go.
not 50%.
Yes, yes, yes. Well,
and I thought Switzerland has been pretty active and also talking to the parliament and you know, making it public and posting it on Facebook, but you never know.
okay, so I see Jordi hasn't typed anything anymore. So, well, let me thank all the speakers for today. Let me thank especially Eric, Silvia, who even flew here, and Eric took a train here to Amsterdam to be with us. Let me thank Fred Baker as well. Thank you very much for being here, and all the rest of the speakers. I'll be thanking them personally in the next few days. I see that 77 people are still present here with us after this long live presentation. We don't have a date set for another Educa in the future, but we're still thinking on the thinking about the topic for the next one. So if you have any suggestions or any ideas, feel free to email us. And this was it. We are going to send you a link later on if you registered for the event with the links to the recordings. So if you missed anything or your connection had issues, you can go back and watch the videos. And again, thank you very much, all of you, for being here. Yes, my colleague is reminding me. We will also send you a link to a survey. So if you look on the right, you have a button that says feedback. Give us feedback, that's written on the right. Please click on that, go to that link, and give us some feedback about what you liked, but especially what you didn't like about this day. Because by knowing what you didn't appreciate, we can only make this better for the next events, for the upcoming events. So again, thank you very much, everyone. And I hope you enjoyed it today. It was fun on our side. It was also a lot of work, but it makes us happy to see that more than 70 people are here still after all this time listening to what we have to say. Thank you very much.
Bye-bye, everyone. Bye-bye, Fred. See you soon. Bye-bye, Silvia. Bye-bye, Max.